Hello everyone, welcome back to coding classes. Today we will create a list which can never lag. The idea is very simple. In this app, we are rendering at this moment around 1 million items, and this is how it looks. So we can scroll it uh, without any lag. If I check the elements in the DOM at the moment, we just have a few items in the DOM. If I count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, only 10 items are in the DOM at any moment of the scroll. I can just keep scrolling it. There is no lag, and the scroll is also very smooth. So the simple idea is that we control the items that will be visible into the DOM. And since the number of items into DOM is limited, the DOM size will be light and it will never lag. Okay, so let's create this list. Before that, I will show you how it looks with normal rendering. So this is the code where I'm just rendering the item, 100 items. At this moment, if I check the DOM, we have 100 items into the DOM, and the list will simply work. If I change the list count to 1000, then let's see what will happen. Now we have 1,000 items into the DOM, and we can see the scrolling is still working. It's not lagging at the moment. Now let's make it 10,000. Now we have 10,000 items into the DOM, and the scroll is not that smooth. You can see when I'm scrolling it, the items are gone and they are taking a moment before being visible. If I reload the page now, I just click on reload. Now let's see how long it will take to reload. Okay. You can see the lag is there and it has started to lag at 10,000 only. And just now we were able to render 1 million items without any problem. So we are going to create that list. Well, there is always a possibility to render multiple items, I mean, 1 million items using pagination. So that's a way to do it. But here we are going to create a virtual, or we can say recycled list, which will help us render 1 million items without any lag. Okay, let's create our list. To create the list, we simply need the reference of our container, which is div here. Also, we have to manually calculate which items to show into the UI, and we have to manually compute where our scroll top is. So simply, I will first create a state in which we will be scrolling scroll top in future. Then we have to store the container ref. Let's link it to the div. Uh, we have stored the reference of this div into container ref. Then we need to define handle on scroll callback. And in on scroll, we will call a handle scroll, where we will simply fetch the scroll top of the div and store that into our uh, state. So we have set it here. We will like to add one console log here as well. Now we have scroll top, we have reference. Now we will like to calculate other things which are like total items, sorry, the total height and the items which we wants to render and the start index of the items which from where to up to which item we want to render the list. Uh, so total height would be the length of items and item height. At this moment, item height is 100 and item dot length will give us the total number of items. So that will give us the total height of the container. Then we have items to render, which we will be calculating soon. For now, we can just assign it an empty array. And then we have start index, which will be scroll top by item height. Okay, let's print them so that we can see if so far everything is working as expected. What's the error? Oh, okay. Let's make it of type number for now. Sorry, array of number. Hmm. Yeah, so far the list is working. We have on scroll handler working fine, which is printing the scroll top for us, and we have the dynamically calculated start index and total height. Now we want to calculate the items which we want to render. So the items which we want to render would be math dot seal container height by container container height by item height plus 2. So basically, uh, this is the count of items that we want to render into the DOM, and this is simple math. We have calculated it by dividing the item height, the dividing the container height, which is the height of this UI page. We can define it as per our use cases. So at this moment, uh, I want to render the items from here to here, and for this I have set the container height to 900, and I've simply divided it by item height, which is basically the height of each item. So this way we can calculate the number of items which we want to uh, make visible into the UI. And to be on the safe side, I have added +2 so that two items are basically ready for us to scroll. We can uh, call it offset and make it 3 or 4, but 2 is also fine because our main purpose is to uh, keep as less as possible items into the DOM, and so 2 is the best number. Now we have items to render as well, and let's see. Uh, yeah, so we have start index 0, total height is 10,000, and items to render is 11. If I scroll it, start index is 1, and items to render is again 11. If I scroll it faster, start index is 55 and total height is constant, which will never change in our case, and items to render is 11. So if you can see, the start index is changing. At the moment, start index is 55. Let me zoom it out. At the moment, start index is 55, and uh, hence it's rendering the items from 56. So you can see start index is 62 and the items are being started from 63. Okay. Now our most of the logic is already ready. All we have to do is just calculate visible items. So to calculate visible items, we have start index. We know the total items to render. So we can simply create calculate end index, which would be this. Now let's print and debug these values before going ahead. So at this moment, start index is 0 and end index is 11. If I scroll it, start index is 18 and item from 19 to 27 are here and end index is 29. So it looks fine. Okay, so now we will create our visible items, which are simply going to be uh, the part of array from start to end index. Let's print our visible items now. Okay, so to print the visible items, we'll have to do JSON stringify so that we can read them here. Okay, so at this moment, the visible items are 19, 20 to 29. If I scroll it, the visible items are 23 to 33. So far, we are on right track. Now we will use our visible items in the DOM. So we just see, we just check the log. We are rendering all the 100 items, and we can see in the DOM we have 100 items at the moment. And as soon as I'm scrolling dynamically, the visible items into the page are here from 1 to 11. When I scroll it, the visible items which are supposed to be 71 to 81 are here into the UI. So if I just use the visible items instead of items, we will again have our required items here. To make it working, we have to do some styling changes as well. So now we will update our elements here. So instead of rendering the visible items directly, uh, we will add one more div here and we will make its position relative with with total height as the calculated height that we just calculated, which was the item's length into the number item height. Then inside this, I will simply loop over all the visible items. And inside this, I will create another div which will render our items. Also, this div is going to have position absolute, and we will define the top and right and left manually. So the top would be index into item height, and the height is going to be the item height. This is it. Now we have created our recycled list. We can just go to our browser and see if everything is working fine. And we can see we are able to render items from 1 to 100, and we just have these many items into the DOM at that particular time. Now, if I change the items count to any number, it will work fine. It will just keep scrolling and scrolling without any lag. I can reload the page as well very quickly because our DOM is very lighter now. So this is gonna work very well. Okay, so our next task is to refactor the code because we have just added everything into the same component, which is not a very good approach. We will create a reusable component here. Let's call it recycled list.tsx. And then we will have a hook, which is gonna be reuse, recycle, scroll.ts. Okay, so we will move all the computation logic to this hook. Uh, Spot const use recycle hook. Let's copy our code from here. So basically, all the logic to compute how many items will be visible and what to show and what not to show will be moved here. Let's fix all the imports. Now we can wrap it inside use callback for so that we don't create new function every render. Okay, we have to pass the dependencies. Then we have to return all the required things here, which are going to be container ref, on scroll, which is going to be handle scroll, then total height and visible items. That's it. So now our hook is ready. We can remove the console log now. It's not needed. Also, one more thing. So we can configure these items from outside. So we can take them as props. These are going to be item height, container height, and items. Okay, so our use recycle scroll is ready. Then let's create our component. I'm just refactoring the code, which is basically copied from here. So there are no logical changes. Then we will simply use our hook here. We will pass the on scroll because now it's on scroll. Okay, so we still need a few items here. So again, we will define props for it. Item height, container height, items, and render item. Okay, so all the errors are also gone again. Then I guess we have defined our JSX logic, which can be generic into recycled list, and we have moved over all the computation into a hook here. Then we will uh, refactor this component to use that recycled list. We can remove these logic. Okay, so we are going to return recycled list. Okay, uh, looks like we don't have any error. Let's go to our browser and see if it works. Yep, it's working. At the moment, we are rendering 1 lakh items, and in DOM, we just have around 10 to 12 items into the DOM. Okay, so still there is room for improving it. So our recycle list uh, component is depending on the item type, which is of type number. So what if I wants to render items of different type here? So I can make it generic. Okay, now this one is generic, and this would be items of index. Okay. Similarly, we might have to make use recycle scroll generic. Oh, okay, so in use recycle scroll, we don't need items because basically we just wants to compute the number of items that are going to visible based on item height and container height. So this can be item count here, and simply this will be a item count. And since we don't have the items here, we can simply return start index and end index, and we can compute the visible items into uh, the component which is gonna use recycle scroll. So we have a start and end index here, and now visible items would be here. Okay, so we have this, then this is gonna be items dot length, and we have to update this code snippet accordingly. So now we are looping over visible items which are of type T. So this is not index anymore. This is item, and here is the index. Now we have to use this as key. So, okay, so let's use a proper key here. I will simply, uh, so first we will use the item here, and then the index. So the proper index of the item is going to be the start index plus the index of the item in this iteration. So the key can be item index, then the top is going to be item index into item, and the render item is also going to take item index. Okay, let's see how it looks now. Yeah, it works fine. I can just keep scrolling up to any number, and if I just see, all I have is these many items into the DOM. So now the code is clean. We can control our styling of the item here as per our use case. Also, it's not very necessary to take the index here. We can probably use any desired key, which can be like this, or in ideal cases, we can use some sort of ID here. Now we can do some more cleanup on our render item. Okay. So you can see now it doesn't matter how many items I render here, either it's 100 or 1,000 or millions, it will just uh, render without any lag. So this was the recycled list. I hope you liked the video. Please subscribe and uh, give a like on the video as well because it will motivate me to create more such videos. I will create a repo and add the link of that repo into the description of the video so that you can see the code as well. Thank you. See you in the next video.